Hey everyone, Mr. Fransky here. Today we're going to be talking about ellipses. That's kind of funny. I just circled it with an ellipse. And so this is another one of our conic sections. Remember, if you have the cone like this, and you slice it with a plane at an angle that is not as steep as the edge of the cone, you're going to end up with this shape kind of like this. It's going to look like an ellipse that's going to cut off part of the cone there. And so today we're going to be able to write equations and graph ellipses, and that's it. So I'm going to go over the derivation of the equation in a different video because that's something you don't have to know how to do. It's kind of cool. It uses the distance formula. But all we're going to do here is we're going to talk about the equation. We're going to talk about how to use it. So vocabulary here, ellipse, foci. So just like that is the plural of focus, right? A parabola had a focus point. It's the direction that it opened, right? So an ellipse has two focus points. They're called foci. That's the plural of focus. Vertices, just like a parabola, ellipse has vertices somewhere, and major and minor axis of an ellipse. So here's our ellipse. And first I want to just define what an ellipse is. The definition of an ellipse is the set of all points in the plane whose distances from two fixed points, which are the foci, so these are our two foci right here, right here, right here, have constant sum. So what that means is in this case, d1 plus d2 is some constant. Okay, it never changes. It doesn't matter if you pick a point here or here or here. The distance, if you add up the distance from the two foci, so if you add up this distance, d1 and d2, that's always going to be a constant number. Okay, so any point you pick on this ellipse will have that property. Any other point will not. So if I pick a point like, I don't know, over here, this point will not have that property that's the same distance from those two as every other point on the ellipse. So every point on the ellipse has that d1 plus d2 is going to be some constant value. That's how you create an ellipse. So the equation for this thing is x squared over a squared plus y squared over b squared equals 1. So whenever you see something in this form, really important pieces are that you have x squared and y squared, right? With a parabola, we only had one of those things squared, and then you have an addition sign in the middle. When we get to hyperbolas, we'll have a subtraction sign there. So you have to make sure you have addition. So that, of course, means it doesn't matter what order you write these, right? It could be y squared over b squared plus x squared over a squared, or the way that it is right now. And it's equal to 1 over here. So this is what's called standard form for an ellipse. Standard form. And we'll talk about the C in a second. But first, I want to talk about what these letters are. So the A value is the distance from the center out to the edge. This is called one of the vertices. The vertices are at the end of the major axis. The major axis is the one that's the longer of the two, and the minor axis is the shorter of the two. So that distance from the center out to the edge horizontally is A. Okay, so A on that side and A on this side. So the entire length from one side to the other would be 2A. Okay, so A on one side, A on the other. The B value is the vertical distance. So it's the distance, it's like half of the minor axis, right? So B is distance from the center to the top. So A is from the center to the right or to the left. B is from the center to the top or to the bottom. And then C is the distance out to one of the focus points. Okay, so we have C there and we have C here. So just like we had on a parabola, the C value is how far it is from the center to one of the foci. Okay? So one of the focus points out there. So we have some relationships. C squared is always the absolute value of a squared minus b squared. Now why does it have to be absolute value? Because we have this ellipse right here that is a horizontal, I would think. I would call this a horizontal ellipse because the major axis lies horizontally. And so A is for sure going to be bigger than B. But if you have a vertical ellipse like this guy, the book does this different than I do. So if you want to use the book way, that's fine. There's some people that like to do it the book way. I like to do it this way. I still say that this distance is A, because then it's easy. The A part, the horizontal part, is always with the X. That's the way I think about it. The horizontal part always is underneath the X. And I still call this value here B. Okay, so B is still the part under the Y, and that's your vertical part. But the foci here are going to be on the major axis. The foci are always on the major axis somewhere. And so the reason I have the absolute a squared minus b squared is because you have to always make this positive. So it might be that b is bigger than a. So in the case of the vertical, c squared would actually be equal to b squared minus a squared, right? But the easy way to think about this is just make the darn thing positive, right? So as long as you have a positive number here, take the square root, that'll tell you how far c is from the center. Okay, so in this case, c would be here and here. All right, so key vocab from this page. Distances from the two foci to a point, if you add them together, you always get a constant. The major axis is the longer of the two axes. So in this case, this would be my major axis, right? Major, and the minor would be this a value down here, right? So the minor would be just this length right here. That'd be the minor axis. And then focus, the foci, right? We have two foci, the focus points on the left and the right, or on the top and bottom here. And then we have our equation here, x squared over a squared plus y squared over b squared equals 1. And then we have this relationship between a, b, and c. Okay, so c squared is somehow a squared minus b squared. So people are like, wait, isn't c squared equal to a squared plus b squared? That's Pythagorean theorem, different thing, right? And if we were adding, then you would end up with your c value outside of the ellipse, which we don't want. They're always trapped inside. Okay. I'm going to prove this in a different video. If you want to go watch it, you can. We kind of did a quick proof, remember, of the parabola equation in class. I will show where this equation comes from. It comes using a distance formula with these two distances added together. We just have to understand that this is the equation of an ellipse, and then we have this relation between a, b, and c. That's really the key takeaways from this slide. So let's try an example. Oh, nope, before we do that. So there's a cool way you can make an ellipse. And it involves just kind of, you can do it with push pins, or actually in class, I'm planning on doing for you, we're going to use suction cups on the board and a string. But because, if we think about this as D1 and this is D2, because the sum of those two distances never changes, if you have a string, right, this and now let's try an example. All right, so our first example is 4x squared plus 9y squared equals 36. So what we're going to do here is we're going to graph it. Well, changes color on me whenever I go off the screen. Let's see if we can get back to our purple. Okay, so we're going to graph it. We're going to find the focus points, or the foci. So foci we're going to do as x, y coordinate pairs. What else do we want? Maybe we find the vertices. Okay, the vertices are at the end of the major axis. And let's find A and B, right? A and B are going to be important to find. So this is kind of just some typical stuff they could ask you for an ellipse. So first thing I'm going to do, this does not look like our standard form, right? Standard form, x squared over a squared plus y squared over b squared is equal to 1. Right now it doesn't look like that. So what I need to do is I need to get a 1 on the right side. So how can we do that? Well, we could subtract 35, but then on the left side I'm going to have a mess. I'm going to have like x squared, y squared, and a subtracted 35. But what we could do is divide both sides by 36. So if we do that, then on the right side we have 1. On the left side, 4 over 36 is x squared over 9, right? Just divide them both by 4. And then 9 over 36 is y squared over 4. People always ask me, do they just switch? And usually yes, but sometimes you'll have a situation where they don't, so don't just assume that they're going to switch. So you have x squared over 9 plus y squared over 4 is equal to 1. So now we can get our a and b values. The a is the part that's stuck with the x. So a squared is 9, so a is 3. B squared is 4, so b is 2. Now we can make our ellipse. Okay. So a is 3, so I'm going to go 3 from the center at 0, 0. I'm going to go 3 to the right. I'm going to go 3 to the left. And then I'm going to go 2 up, and I'm going to go 2 down. And we're going to put our points in there. The vertices then are at negative 3, 0 and positive 3, 0. Those are my vertices because they're in the major axis. That's the longer one. Now, drawing an ellipse sometimes is kind of tricky. Oftentimes people kind of end up with pointy things at the ends, like, or it kind of looks like a diamond. What I always think about is when you get to an axis, you should go straight at it. So I'm going to come straight out, and then I'm going to come down, and I should go straight down. Okay, that wasn't great, but it's not terrible. Okay, and then it's going to go straight down and straight in, then straight out again, and it's going to come straight up, and then straight up and straight in. It'd be better if I had drawn the left ticks a little bit closer together. Okay, but that's our ellipse. That's what it looks like. So graphing an ellipse, not bad at all. You just have to get the horizontal part from the x, the vertical part from the y, and then you plot the vertices, and you're done. Now we have to find the foci. So to find the foci, what we have to do is we have to find c. So c squared, remember, is the absolute value of a squared minus b squared. Now we can use this equation, but I'm just going to do the bigger minus the smaller. So c squared is going to be 9 minus 4. You can get that from right here, just the bigger minus the smaller. So that's 5. So that means that c is the square root of 5. And you're like, Mr. Fransky, we don't know what the square root of 5 is. Well, we can kind of guess though, right? What is the square root of 5 between? 2 squared is 4, right? And 3 squared is 9. So the square root of 5 must be somewhere between 2 and 3, because the square root of 4 is 2, the square root of 9 is 3, so the square root of 5 must be somewhere between 2 and 3. And I think it's going to be closer to 2, because it's really close to 4, right? So it's just going to be just on the outside of 2, and just on the outside of 2 on this side. Okay, and those are our foci. So the foci are going to be at positive root 5, comma 0, and at negative root 5, comma 0. Sometimes you see people do this, plus and minus root 5, comma 0. That's fine with me if you want to do that. Okay? All right. So graphing an ellipse, not that bad as long as you have your equation in standard form. Let's try another one. All right, this time we have it in standard form. So we have x squared over 16 plus y squared over 49 equals 1. So our a value here, it looks like is 4. That's the square root of 16. Our b value is 7, right? So the horizontal part's 4, the vertical part is 7. So this is going to be an up and down ellipse, right? It's going to be vertical. So let's get a graph of that right here. So we're going to go up 1, 2, 3, 4, 5, 6, 7. Down 1, 2, 3, 4, 5, 6, 7. Left and right, we're going to go 4. 1, 2, 3, 4. 1, 2, 3, 4. Dots everywhere. So this time the vertices, remember always at the end of the major axis, are at 0, 7 and 0, negative 7. So we're going to connect the dots. Remember going straight out and straight in, straight out and straight in, straight out and straight in. I'm not going to grade you on your art, but it should look like an ellipse, right? Kind of looks like a potato. All right, now so we have our vertices, we have our a and our b value. The length of the major axis, I didn't do this on the last one, but I'm going to do it if they ask. The length of the major axis here is 14. The length of the minor axis has length 8, right? Because it's 2 times 4. Now let's find our c. So c squared, remember absolute a squared minus b squared. So in this case, I'm going to do like 49 minus 16, right? So c squared is 49 minus 16. That is 33. So c is the square root of 33. Now what's that between? Well, it's between 25 and 36. So then that must be between 5 and 6. So go 1, 2, 3, 4, 5, just between 5 and 6 right here somewhere. And then down 1, 2, 3, 4, 5, somewhere between 5 and 6 here. So our vertices are going to be at 0 plus and minus root 33. There we go. Okay, and that gives us a nice picture of our ellipse. That's really all you have to do. So you can tell the foci really aren't important to the graphing, but they're really important to the creation of the ellipse, right? That's the point where, those are the 2 points where if you add up the sum of those 2 distances, you're going to have a sum that's a constant no matter where it is. All right, I think I got one more, maybe 2. Nope, this is the last one. All right, so an ellipse has foci 0, negative 3, and 0, 3. The minor axis has length 4. Find the equation and sketch it. So this is one of those where we're given some information and we kind of have to figure out what's going on. So as you know, I always like to draw pictures. That's what I'm going to do. So if I draw a picture, So draw a picture here. Oh, come on. Give me a pen. There we go. So draw our picture. 0, 3, 1, 2, 3. There's one focus. And 0, negative 3, 1, 2, 3. There's our other focus. So our C value we right now know is 3. And it's a vertical ellipse. It's up and down. So that means the minor axis is going to be horizontal on the x-axis. So the minor axis has a total length of 4. That would be 2 to the left and 2 to the right. Okay, so those are the endpoints of my minor axis. So we know right now that A is 2. Okay, so that distance to the left, distance to the right is 2. So now what we have to do is we have to find B. I don't know what B is. So this is where it kind of becomes important to know that equation, that c squared equals absolute a squared minus b squared. That helps us, but we have to know at this point, which one should be bigger? Should A or B be bigger? Well, it's a vertical ellipse because the foci are on the vertical axis, so I think B should be bigger. So in this case, c squared is going to be b squared minus a squared. Now we plug in what we know. C is 3, so we have 9 is equal to b squared minus, not equals, minus a squared, which is 4. So we add 4 to both sides. We have 13 is b squared. That means b is the square root of 13. Okay, so b is the square root of 13. That's something between, what, 3 and 4? So 1, 2, 3, here's 4. So b is going to be somewhere up there and somewhere right there. Okay, so here's our ellipse. I mean, very, like, kind of skinny. That's what happens when those foci get really close to the edge like that. Okay, There's our ellipse. Now we want to get an equation. So remember, it's go away. Gosh, got a new computer, and they got keep touching it and it does weird things. All right, so change my color too, of course. So we know it's x squared over a squared plus y squared over b squared equals 1. So we know some of these things. A is 2, so it's x squared over 4. Y squared, now we have b. B is root 13, but I've got written right here, b squared is 13, so I got it right there. Equals 1. That's your equation. Awesome. Foci happen at 0, plus and minus 3. They told us that. Major axis would have length 2 root 13. Minor axis has length 4. Not too bad. All right, that's it for your intro to ellipses. One thing I do want to say, you may have noticed this kind of the equation for an ellipse kind of looks like the equation for a circle, right? The equation for a circle is x squared plus, oh my goodness. The equation for a circle is x squared plus y squared equals r squared, right? And this is just if you divide both sides by r squared, you have x squared over r squared plus y squared over I squared is equal to 1. And that is just if a and b were the same value, right? If a and b were the same value, that makes sense, right? If you go out a left and right and up b left, up and down, you would end up with a circle because the vertices would be the same. And the foci would be right at the center. The two focus points would be moved right up to the center. All right. Sorry, I tagged that little end on there. I want to make sure I talked about that. That Desmos simulator is on Schoology if you want to check it out. Otherwise, I will see you in the next video. We're going to start moving these ellipses around. Love you guys. That's why I'm here. I will see you soon.